Hi everyone! Today's lesson focuses on the learning goal, what does negative mean? And it's an introduction to lesson 2.1.3. Please take notes as we watch and bring them to class with you tomorrow so we can discuss and do more examples together. Today we're looking at this symbol right here. Alright, and that symbol goes by a couple of different words, or we refer to it a few different ways. Oftentimes we just say, we read that as minus, right? Like 5 minus 3. We can also use that when we're talking about like taking something away. So you might say 4 take away 2. Again, that's using subtraction. We see that symbol when we're learning about negative numbers. Okay, so you could read that as a negative sign. Also, today we're going to focus on using it to mean the word opposite. Okay, that's one we don't always refer to in math, but we're going to use that a lot today when we're working with tiles and the distributive property. So that sign can be minus, take away, negative, or opposite. This is a picture of an expression mat. Now you guys might have used some mats last year to build with tiles, but this year we're going to use mats that are split into two regions. Up here you'll see we have the positive region, and then down below we have what we call the opposite region. I'm just going to label that there. Okay, so the top is the positive, the bottom is the negative region or the opposite. Okay, and as a reminder, remember that when we're working with tiles, when they're shaded in, that's a positive, and when they're left white, that represents a negative. Okay, so if we wanted to build the expression, if we wanted to just build the number 3, we could build that on our expression mat in a couple different ways. I could just simply draw 3 positive tiles up on top, right? We've got 1, 2, 3 in the positive region. That's one way to show it. Another way that we could show that is to build 3 negative tiles in the opposite region. So this is like -1, -2, -3, but they're in the opposite region. So it's the opposite of -3, which we know the opposite of -3 is just 3. Let's take a look at another one. We want to build -2x. So one way we could do that is to put 2 negative x tiles up in the positive region, right? We have -x and another -x, and that's going to make -2x for us, okay? And then a second way we could build -2x is we could think of that as the opposite of 2x. Or we could take 2 positive x's and put them in the opposite region, or that negative region. And so when we're looking at this, this is like the opposite of 2x, which again is equal to what we were building up at the top. Let's take a look at another one. Here we have the opposite of 2x plus 3. So when I go to build this, what I like to do is I'm going to take everything that's inside these parentheses and I build it just as it is in the opposite region. So first I'm going to build 2x down here. So there they are. And then I'm going to build the plus 3, so 3 positives, okay? But they're all down here in this negative region, or in the opposite region. So when I go to simplify this, I'm thinking to myself, well, I've got a -2x, or the opposite of 2x, plus I've also got a -3. Okay? This expression up here is equivalent to this expression down below. And what happened is we actually distributed this negative to both of the terms inside our parentheses. All right, let's look at this example. This one looks a little trickier. This one we have the opposite of -5x plus 3. I, again, always like to go inside my parentheses first, and I'm going to build this exactly as it is, but I'm going to put it down in this opposite region because of the negative on the outside. All right, so -5x, that's 5 of these, 1, 2, 3, 4, 5, and then we're adding 3, so that's 3 positives. Okay, and we've got it all down here in this opposite region. Okay, so now if I want to simplify this, I have to think, what are the values of these tiles actually? So I've got the opposite of negative 5x. And I've also got, so I'm adding, I've also got the opposite of 3. So plus the opposite of 3, or negative 3. Now this still isn't really this isn't simplified. I want to make this look even nicer here. So I have the opposite of negative 5x. Well, that's just 5x plus the opposite of 3. Okay, so this expression here is equivalent to our original one. Just a different way to write it. Try this one by yourself for a second. Draw a sketch of an expression mat on your paper, and then draw a sketch of what the opposite of y minus 2 would look like with tiles. Simplify it, and then come back to the video and see how you did. Alright, so I'm going to build y minus 2 in the negative region because of this minus sign out here. Okay, remember, another way to think of y minus 2 is y plus negative 2. Right, so I'm going to make my y tile, that's that long skinny one, down here, plus 2 negatives. Alright, so let's simplify it to see what I have. Well, I have the opposite of y, which is negative y, plus the opposite of negative 2. Well, I know the opposite of negative 2 is just 2. So here's my simplified expression. Let's see what this looks like without tiles. Okay, so we have an expression here. We can think of this as the opposite of everything that's in parentheses, or we're subtracting everything that's in parentheses. And what you're doing here is you're thinking, okay, what is the opposite of negative 4? Well, the opposite of negative 4 is just 4, right? And then I have subtraction going on here. And then I want the opposite of this x. Well, that's a negative x, right? So we have 4 minus negative x. Well, now I know subtracting is the same as adding the opposite, so I can do my double slash there, and I see it's the same as 4 plus x. This expression looks much nicer than our first one did. There's kind of another way you could have looked at this too, right from the beginning. If we had our original expression, you could have turned it into addition right away. We have a minus x here, and we know subtracting is the same as adding the opposite, so I turn it into plus a negative x. And then when I go to kind of distribute that negative, I say, well, the opposite of negative 4 is 4 plus the opposite of negative x, which is just an x. That kind of saved me a step in between. It's up to you which way you like to do it or which way makes more sense. I'm just going to show you a couple there so you can decide. Alright, this will be our final example. This problem says 5x minus 3 minus 2x. So we can think of this 5x is going to just stay put, right? And then we can say we're subtracting everything that's in parentheses, or we're taking the opposite of everything that's in parentheses. So we can do 5 minus 3, or the 5 and then the opposite of 3. And then I've got this subtraction symbol I need to bring down. And then I have the opposite of 2x, which is a negative 2x. And then I'm going to go through and kind of simplify here. I see I have 5x minus 3, that's like 5x plus negative 3. And then subtracting that negative is like adding a positive. So I can look at this expression now and combine terms to simplify it even more. I have 5x plus 2x. Well, that's 7x. And then what I'm left with up top here is this plus negative 3. Or you could do 7x minus 3. Either one works. Okay, so we took that big expression and simplified it by breaking it down into steps. A different way we could have approached this one from the beginning is we could have gone through and turned all of our subtraction into adding the opposite right away. Some people prefer doing it this way, and then they can just bring down what we have, 5x plus, now we've got the opposite of 3, which is negative 3, plus, I'm using my addition symbol there, the opposite of negative 2x, which is just a positive 2x. And again, now I can combine my like terms to get the same expression as before, but just in a little bit different way. All right, so tomorrow we'll go through this more in class. Bring any notes that you took with you and any questions you might have. Thanks for watching.